Welcome to the second episode of the Design Future Manufacturing series. This time we are going to investigate how Mitsubishi Electric is supporting future manufacturing in terms of drive solutions. Let's first move to Nagoya Works, the heart of our factory automation division.
The history of Mitsubishi Electric frequency inverter starts in Nagoya Works. Nagoya is the heart of our factory automation division, which incorporates various product sections such as PLCs, HMIs, servos, and of course frequency inverters. From 1981, when the first inverter called FRE was manufactured, we are globally recognized as a leader in terms of design, manufacturing, and sales of industrial variable frequency drives. For many years, we have always been known for versatile and extremely reliable drives, working even in the harshest industrial environments. Today, our variable frequency drive family is welcoming a new member, the FR E800 generation, which apart from very well-known reliability, will offer its users something more. It will open the gates to future manufacturing.
Today, in our studio, we are with Wojciech Bracha, Product Manager for Variable Frequency Drives. The FR E800 new generation of drive in the Mitsubishi Electric Frequency Inverters family is appearing in 2020 and is announced to be a drive designed to meet future manufacturing needs. What main idea underpinned the development of the new generation of FR E800 drive?
If we go back to the past, when the first concept was made, there were four main principles which underpinned the design of the FR E800. First of all, it was supposed to be an IoT drive, which would support network connectivity ready for the smart factory. Secondly, as a machinery drive, it should follow recent functional safety requirements, which are becoming increasingly popular. In addition, similarly to our past product development, the new series was expected to offer further smart drive features and utilize cutting-edge AI technology. And last but not least, the expectation of our customers was also to make it as universal as possible by offering various motor types connection as well as motor control methods.
Well, if we take a closer look at the FR E800, you will notice that it literally offers all possible drive functionalities, which until now were available only in the flagship models.
Indeed. In fact, if we take an even closer look, you might find that the new generation of FR E800 in some cases offers even more. For sure, we can frankly say that it's a flagship drive performance in a compact body.
Let's focus for a while then on networking. In the previous episode, we have heard already about CC-Link IE-TSN, but the FR E800 seems to be a bit more than just a drive, which supports a time-sensitive network.
True. In Mitsubishi Electric, we have identified that more and more drive solutions present on the market are network-oriented. As an example, we can consider one of our customers, who is a supplier of complex production lines for material transport and packaging. This company is typically supposed to integrate new lines in existing control systems. Due to a wide portfolio of end customers, they face a situation in which the delivered packaging line must work well with the industrial network that is already present in the factory. Integrating drives in existing control systems can sometimes bring a challenge related to proper data exchange and the control itself. And here, the FR E800 comes along as a solution, which is an open network drive and supports various embedded industrial networks, such as Profinet, Ethernet IP, and EtherCAT.
An open network device. It looks like we have a proposal for someone who's want to make their life and work easier.
Exactly. Thanks to this, no additional network interface is needed. It simplifies the network infrastructure, allows for component reduction, and on the top of that, makes the programming easier. As a result, integration of the whole control system is easier, allowing for time to market reduction and finally, saving costs on both hardware and human labor.
The dual Ethernet port is also worth mentioning, right?
Indeed. In addition to all this, utilizing the dual Ethernet port, we can imagine that designing the network infrastructure becomes much easier and offers more flexibility. For instance, we can choose between line, star, or ring topology. The dual Ethernet port allows for reducing additional network components such as switching hubs by connecting one drive to another. This brings additional savings on hardware and wiring costs, especially in decentralized systems.
All these features make the FR E800 a very universal drive. How is this versatility supported in other areas?
With an increasing need for very precise control, we decided that the FR E800 will be a drive which will allow for the most precise control of various kinds of motors. That's why it supports closed-loop full vector control for all kinds of motors, including high-efficiency, permanent magnet and reluctance motors. Regarding versatility, it is also worth mentioning a full-scale PLC which is built into all FR E800 models.
Well, it seems that a PLC built inside of a drive offers its users much more flexibility. Does this mean that we can give up having an external PLC and program our application just using the drive?
In many cases, yes, but there is something more. Of course, utilizing built-in PLC is one possible usage, and obviously it will bring us savings on hardware. But it also makes our life simpler when we consider creating out-of-the-box drive functionality, which is not typically included in its parameters. 10 years ago, when a drive was supposed to be equipped with new functionality, there was a lot of workload behind this, starting from the development of drive firmware by programmers, through updating of documentation such as manuals, and finishing with upgrading on the production line. Now, the customer is provided with the possibility of doing their own drive function development using ladder, function blocks, or structured text, which definitely shortens the time needed to achieve the requested functionality. Finally, you can be an architect of the drive and design future manufacturing.